Καλησπέρα σας, καλημέρα. Δεν χρειάζεται να πούμε και τίποτε σύνθημα. Είμαι ο Kypros Milidonis, είμαι από το Cyprus Institute. Είμαστε εκεί ακαδημαϊκοί, ερευνητές. Θα σας δείξω σήμερα τι κάνουμε εμείς τι κάνουμε σαν ερευνητές. Δεν έχει κάποια σχέση άμεση με buildings των συνεδριών, αλλά είναι ένα καλό introduction για το τι θα σας δείξει ο συνάδελφος μου Αλαρίξ στο συνέχεια, που θα σας δείξει applications to solar thermal technologies, to concentrated solar thermal technologies, same building applications, okay? So, να σας δείξω εγώ, can you put the... Εγώ θα σας δείξω, θα σας κάνω μια μικρό introduction στα concentrated solar thermal technologies and how we can, the research that we do, and I will show you the biggest research infrastructure in Cyprus that we maintain and we operate as the Cyprus Institute, and its main research lines, okay? So, this is a brief overview of my presentation. I'm going to introduce to you in simple manners what is concentrated solar thermal technology, the types, the thermal energy storage concepts, residential and industrial application of CST, and then I will show you what we really do at our facility in terms of these CST technologies, as we call them. I will show you a brief overview of the research facilities, the activities, the brief history of the facility, the layout, the current state that the facility is working on, and the main components of the sound system. So I'm not going to go into scientific detail. It's going to be mostly educational and what is the real, how do we do these things, okay? So you all know about photovoltaics, okay? That we take the energy, we transform directly from solar radiation into electricity, and the main storage system is in the chemical energy, is terms of battery storage, okay? This has nothing to do with concentrated solar thermal. In concentrated solar thermal technologies, we take the sunlight, we transform it into heat, and then from the heat we can transform it into electricity and other applications that you're going to see in next slides, and commodities, okay? The important thing to understand here is that we are able to store energy in terms of heat, okay? So it's called thermal energy storage. We're going to understand what it is later on. So what is concentrated solar thermal technologies? What is the basic idea behind this thing? Okay, so a plant, a CST plant, is usually composed of three subcomponents, subsystems. It's the solar field, the thermal energy storage, and the power block. Okay, so this thing here that you see, the solar field is composed of a big array of mirrors. These actually are mirrors, very clean mirrors, that we collect and concentrate the sun radiation into a receiver. When I say concentrate, these mirrors here are not flat. They have a parabolic shape, so they can have a focal length. So we match the focal length to the distance of each of these rows to the receiver. From there, we increase the temperature of the heat transfer fluid. Usually, this heat transfer fluid is a salt mixture. It's actual salt. It's potassium and sodium nitrate. Okay, it's a mixture of potassium and sodium nitrate. We melt the salt and we transfer the salt into the thermal energy storage subsystem, which we have a hot tank, which is a hot salt between 300 and 515 degrees Celsius. We then put the energy into a power block. This is a typical power block that you use in, let's say, Basilico. It's a steam turbine working on a Rankine cycle, for those of you that are familiar. And then we take again the cold salt, we pump it up to the receiver, and we do the loop again, okay? So, what are the main, let's say, types of CST, concentrated solar thermal technologies? Usually, we separate them in two categories, the linear focusing systems and the point focusing systems, okay? In the linear focusing system, you can see we have the parabolic trap systems, the linear Fresnel systems. What do we mean by linear focusing system? We mean that we collect and we concentrate the sun rays into a line, okay? This is the line here that we concentrate the sunlight. And in the point focusing system, we concentrate the sunlight into a single point, okay, more or less. This is what you see here for these two, the parabolic dish and the central receiver system. Okay, in the parabolic trough, Andrea, can you press the video? This is the parabolic trough. It's composed of U-shaped, let's say, mirrors that have a focal length. The parabola has a focal length in the middle, somewhere here. And Andrea, can you play it? Okay, so you can see the operation of the parabolic trough there. This is the mirror. In the focal line, there is a piping there that we push through a heat transfer fluid. And the heat transfer fluid, we pump it into the thermal energy storage. And from there on, we do the production of generated electricity or other things that we need with heat, okay? So this is the parabolic trough. It continuously tracks the sun, okay? So we can maximize the efficiency. The other linear focus system is the Fresnel system, which is composed of linear, let's say, longitudinal mirrors that again concentrate the sunlight in a central receiver system, which is a pipe. Andrea, can you please play the video? This is how a linear Fresnel system works. You can see the sunlight, you can see the linear mirrors. These mirrors actually have a small curvature in order to create the parabola again. And you can see the mirror here following the sun, okay, and concentrate the sunlight inside a tube, as you're going to see now. This is the tubing on top. The heat transfer fluid is in there. We take it into thermal energy storage, and again we transport it either to a power generation block or process heat. Okay? So, parabolic dish point focusing system is a big dishes that in the focal point we have and let me play it. We have a so-called Stirling engine. It's an engine that transforms heat into electricity indirectly. Again, the system tracks the sun continuously and generates direct electricity that can be sent to the grid. You can see the thing now focusing and tracking the sun and sending electricity directly to the grid. Okay, so the last one is the most, this is the central receiver system. It's one of the most commercially developed plants around the globe. What we have here is a field that is composed of several mirrors. These mirrors are called heliostats. Andrea, can you play? Heliostats are some devices that continuously track the sun in two axes. Okay, like that, azimuth and elevation. This thing here is all these small blue that you see here. And all these things are concentrating the sunlight in a central receiver system where we are running again our fluid. You're going to see now the Andrea can play. You can see here the operation. We have a cold tank around 219 degrees Celsius, molten salt. We pump it into a central receiver system that is heated by the heliostat. We pump it down, we take it to the high temperature tank, and from there we drive. From there you can see that we use a heat exchanger to transform water into steam, to feed a steam turbine block and generate electricity. This is the main concept of solar power systems. Okay, so this is some commercial plants around the globe. Actually, this tower here that you see that has the receiver on top is 160 meters. So this thing here is like 1.5 kilometers. So you can understand the size of the things. This is in Nevada, 110 megawatt. This is solar tower system. This is parabolic trough. This is Fresnel system in China. Okay, and this is some Stirling engine plant that is installed. Okay, so why thermal energy storage is the most important thing to understand here, because this is what we need in order to have dispatchable electricity when we need it. Okay, so as I told you before, it's very, you can see this sentence here, transporting heat is much more difficult than transporting electricity, as you know, because you can put a wire, you can transport electricity. But if you want to store electricity, it's much harder and much more expensive than let's say, storing heat. So that's what we do. And I told you that thermal energy storage is an integral part of the concentrated solar thermal component, because it can give you the ability to be indispatchable. And what we mean indispatchable is that when you can provide the power when the grid needs it. Okay? And of course, during the night, you can have a concentrated solar thermal plant operating 24/7 with no interruptions. I mean, you can understand that if you have a PV plant, you cannot do that because when a cloud comes, it covers everything, then you don't have electricity, the grid goes down, so you need to implement storage. And if you want to implement storage with batteries in photovoltaics, it's very expensive, as you see here. Okay, this is the levelized cost of electricity for CSP, 9 hours of storage compared to the PVs. Okay, so you can see that is, if you want to put the battery cost inside the equation, then CSP is very, very effective. Okay, and of course, as you're going to see later on, in these facilities we use, as I told you before, molten salt as the heat transfer medium and for the thermal energy storage. And apart from electricity, concentrated solar thermal technologies can assist both residential applications, also industrial applications, as you see here. The applications are numerous. My colleague Alari is going to show you in the next presentation a space and heating and cooling application of CSP. Of course, as we are here, we are interested in collaborating with industries and local industries and foreign industries. We're already doing it, but we want, with foreign industries, we're already collaborating a lot. But with Cypriot industries, we want to collaborate more because there is potential. You can see that the process heat that comes out of this kind of system, you can do ceramic industry, steam industry, mining, desalination, drying, firing, food industry, for everything that you see here, chemical, plastics, textiles, and stuff like that. But we also have the ability to go in high temperatures, as you see here, in excess of 800 degrees Celsius, where we can do thermochemical hydrogen production, we can synthesize gas, we can do methane cracking, biomass gasification, we can test converters, you can even do space applications, something that we do now. We can test high temperature materials, we can use the heat for the steel industry and glass production, and of course calcination of cement, lime, magnesium. So you can see that concentrated solar thermal, it's a technology that does not only provide electricity, it can provide heat, process heat, and also high temperature heat for industrial applications. Okay? So, I hope you understood now what concentrated solar thermal technologies are. I'm going to show you what do we do in our facility. So, Proteus technology, Proteus stands for Platform for Research, Observation and Technological Application in Solar Energy. It is currently the biggest research infrastructure in Cyprus and probably around the Middle East region. Okay, the facility is devoted to research, innovation, development and testing of novel components, but we mainly focusing on solar energy. Okay, but we do other stuff also, as you see here. I will show you actually about smart grids. We have a small microgrid built in there. We do smart monitoring and control, pooling generation systems, multi-storage, thermal desalination and brine management, because we need water in Cyprus. As I told you before, as a byproduct, we can use the waste heat of the plant to generate desalinated water. We do innovation. It's part of our nature as research lines to develop innovation and provide innovation potential for Cyprus. And we offer our facility from people across the globe that they come there, they test their facilities. We provide a very nice test bench under realistic conditions to test their prototypes, to test the novel systems, components, anything you can imagine. I mean, even accelerated aging of materials and all that stuff. Okay, so the reason we are here is to show you that we want to bridge the gap between the fundamental research and the industry of Cyprus to help you, let's say, reduce your carbon emissions and help you to do your industry more sustainable. Okay, a bit of history of how we started. We vision the Proteus facility, we vision it as a platform where we can do electricity cogeneration with desalinated water. We started in 2008 with the original concept formulated, then lots of research and research money. We went up to 2017 where we actually matured this technology of cogeneration of electricity and desalinated water in 2017. But after years of research and development, 2021 we started expanding our facilities, and now we are here. We have expanded to a polygeneration, hybridization, and multi-storage system as you're going to see now. Okay, so this is our facility. It's located, Andrea, can you play the video? Okay, it's working. This is our facility. It's located at Pentacomo, near Limassol, here. White Rocks area, you can visit anytime you want. This is labs and machine shop, photovoltaics, central receiver tower system as I showed you before, high quality baseline surface radiation network is a high-end meteorological and solar resource capturing machine here, meteorological station, a wind turbine, Stirling dishes, desalination units, and all of these are connected into a very nice way in a small microgrid I'm going to show you now. And we do research in almost every aspect of renewable technologies. Okay, mainly we're focusing on solar, but we do everything. Battery storage is in here. This is our control room. I will show you later. So this is an overview. Okay, we have battery storage, photovoltaics, machine shop offices, technician offices, control room, because everything needs to do, all of these are controlled with specific software and tools. A heliostat field that reflects the light into this building here. The building here has the receiver inside and the thermal energy storage, desalination, meteorological station, warehouse, wind turbine, and Stirling dishes. This is a brief overview of our facility. Okay, so how are these connected together? This is the microgrid scheme that we have implemented. You can see that we have CSP technologies, concentrated solar thermal technology in terms of Stirling dishes and tower systems. We have two Stirling dishes as you saw, 10 kilowatt electric each. We have a solar tower system that is 210 kilowatt thermal, wind power, photovoltaics, and everything is controlled via a hybrid inverter that we have developed. Of course, you get the heat from here and you charge the thermal energy storage. This is full of molten salt. We have 1.6 megawatt hours of storage. Of course, we have the battery storage, 110 kilowatt hours. And from here, you can see that we run our power block via steam turbine. We do heating and cooling. We output process, industrial process heat. And from here, we go to our desalination unit from the waste heat. And we run desalination. That's why we're also on the shore. We get seawater we pump seawater from the sea into our facility, and we produce desalinated water. Yeah, thank you. Finish. So this is a facility that does hybridization of the two CST systems, photovoltaic systems, and wind power. Mostly all the forms of renewable energy systems. Okay, and of course we have multi-storage, thermal energy storage, battery storage, and simultaneous production of different commodities, apart from electricity, right? So the tower that you saw earlier, this is the main components of the CST tower system. These are the heliostats that are tracking the sun as you saw earlier. This is our receiver. It's a cavity receiver that you concentrate the sunlight in there. There is a salt behind it. The salt is pumped. The salt is pumped downstairs. The hot salt is pumped downstairs. This is thermal energy storage. This is a heat exchanger that we have inside the molten salt that will produce the steam for the power production. The design of this thing is patented by us. It's our design, our patent, and pretty much this is the heart of the operational system of our solar tower system. And these are some pictures from the desalination unit for osmosis, the multiple effect distillation machine, the solar Stirling dishes, the tank, the power block. And I think this is it from me. I think I'm in the time. If you have any And if you want to visit the facility, you are most welcome. Let us know, and we are happy to show you around in our facility. Okay.
Λοιπόν, να ευχαριστήσουμε τον δόκτορα Κύπρο Μιλιδόνη. Θα κανονίσουμε μια συνάντηση με τους συναδέλφους, οργανωμένη, για να μας κάνετε μια ξενάγηση του χώρου σας. Ερωτήσεις, αν έχει κάποιος?
Yes.
My name is Dimitris Karlakopoulos. Do you have any indication on how much solar energy you can get right now in Cyprus and what
Solar energy, you mean in terms of power? So in Cyprus, during, let's say, we have a lot of measurements like from the last 10 years. I can tell you that we can get roughly 850 watt per square meter in Cyprus where there's sunshine, the average.
the percentage of the energy that you can harvest right now and what you think it's a feasible number in the future to harvest as per your requirements, Cyprus requirements in energy?
And if you mean if we can power with such a plant the entire Cyprus, yes. I mean, I think we calculated that you need like a land of 1 by 1 kilometer, something like this, and you can put something like this and you can power the Cyprus. The thing that is the most important for this kind of technologies is the chip storage. And it's a storage system with molten salt. You heat you storage in terms of heat, thermal energy storage. So these molten salts, they don't deteriorate, nothing can happen to them, you can run it for like 25 years, no problem. If you try to put batteries, of course, batteries have a very short discharging cycle. The cycles that you put the charging and discharging cycle destroy the batteries, so you have to replace the batteries, which are very expensive. So, I mean, if you consider that to store 1 kilowatt of electricity in batteries, you need approximately $230 now. To store 1 kilowatt of heat in terms of molten salt, you need like 20 euros. It's nothing. So,
have you considered using generating hydrogen?
Yes, I mean, one of our business lines now, we're actually trying to expand the facility into hydrogen production. When I mean hydrogen production, I mean we are going to high temperature hydrogen production with not the typical electrolyzers that you have, because those are very limited in terms of efficiency. We are going to high temperature electrolysis. Don't know if you know the solid oxide electrolyzers. And we want to go there because are highly efficient, and because we can get the heat that requires to drive such systems. That's our main route now. So yes, we are doing stuff like that.
Thank you very much.
No problem.
Εάν δεν υπάρχουν άλλες ερωτήσεις, Κύπρος, ευχαριστούμε πάρα πολύ για την παρουσίαση.